Alright, now that we have a data table and a decent graph, I want to show you something that I will ask you to do to add detail. We can move the graph to the side, click and drag it over. I will ask you to type in a cell the word equation, and what we'll do is we'll click on that cell and we'll insert a note. And we can start typing here. What I'd like to do is retype the equation with better symbols. So force equals, what I see down below is 0.252 times x, not x in this case. A better name for the variable is stretch. And then we'll add to it our intercept value, which in this case is a negative minus 0.042. And the units, well, we don't have units yet. That's what the equation should be down below. In fact, I'm going to make that force. So that's what I would like to see. Now, we still have to explain what those numbers mean. Those numbers have units on it. So the slope, let's write the meaning of the slope here. In this case, for every 1 centimeter of stretch, the force increases 0.252 newtons. So that's the meaning of the slope, and the y-intercept write a similar sentence to describe the meaning. And here is such a statement. When there is zero stretch, there is negative 0.042 newtons of force. That's the meaning of the y-intercept in this case. So that presents a dilemma here. Does that make sense? When there's no stretch, there's actually a force and it's negative. Doesn't seem to make sense here. So we have to think about what we're looking at. And even though this looks like a perfect straight line, it's not. The data point, these measurements include some uncertainty, and the line does not go right through every point. And that is natural. The uncertainty in the measurements will cause them to vary from what might be a true linear relationship. And so we have to understand that. And a consequence of that measurement uncertainty, the error in our measurements, creates a small negative y-intercept. And so we have to interpret that. Now in this case, I might expect the y-intercept to be 0 when there's zero stretch, there's zero force. And if that's what I expect, then I would look at that and think, well, that is a very small number. It is close to 0. So my final interpretation would be that I should consider the y-intercept to be 0. So I would write something like this. The expected value for the y-intercept is 0 newtons. The small y-intercept value is a consequence of measurement uncertainty. I will interpret the intercept to be 0 newtons. And with that statement, I can write a final equation that looks like this. Force equals 0.252 newtons per centimeter is the slope. I want to get the units on there, and I didn't have that in the previous version. Times my stretch, which is the horizontal axis variable, and since I'm considering the slope to be 0, I can leave it out, but I will type it in here just for completion, and I have this, and you can make that larger, and there is the total note now. That is a full explanation of the meaning of the features of this linear relationship, which is the result of the data collection that we did. So the note is there, even though it will disappear if you left click. It shows up and you can look at it, and when you print this out, it will print out a second page with this note on it. So this is how I can view it if I'm looking on the computer, and if you print it out, it can also be